same thing. This is just another example. Eliminate the parameter. This is a harder one. And this ties it into trig. So same instructions. X equals 7 sine t. Y equals 7 cosine t. So the last problem, we eliminated the parameter. We eliminated t by solving for t and plugging it into the other problem. That's not always the best thing to do. In fact, this one is quite frequently, if you started trying to do this by solving for t, you would have inverse sine. T equals inverse sine of, what would it be? X divided by 7 or something like that. And then you would plug that into the other ones, so you'd be going y equals 7 cosine of inverse sine of x over 7 or something like that. I don't know. That just gets really messy, right? So there's got to be a better way. Well, do we know any identities that involve just sine and cosine? Ooh, there's a Pythagorean identity that my honors classes have been learning the identities, so it's actually already written over there, that relates sine and cosine to each other, right? So instead of solving for t, could I just solve it for sine and for cosine instead? Okay, so let's solve this one so that it's sine t equals x divided by 7, and then we're not going to worry about doing an inverse to get t by itself. And then we're going to solve this one for cosine t, so cosine t would be y divided by 7. And then we're going to use an identity. You knew this had to fit into trig somehow. Sine squared theta plus cosine squared theta equals 1. So, since we have the sine of t equals x over 7 and the cosine of t equals y over 7, since they're both the same angle t, can't we just substitute those in place of the sine and cosine into our identity? Okay, so we can replace sine with x over 7 squared, replace cosine with y over 7 squared. That gives us x squared over 49 plus y squared over 49 equals 1. And if you really wanted to put this in a form that you can recognize, you'd multiply the whole problem by 49, which would give us x squared plus y squared equals 49. Does anyone recognize what shape this graph would be? It is a circle, yes indeed. But because the parameter is all real numbers, it doesn't have a particular starting and stopping point on that circle. It just basically goes around and around and around and around the circle. So the domain would have to do with the circle, not with t. Should we graph it really fast to make sure we understand? Cool. Glad you like it.
No, we'll do the circle. I like circles.
So our object is moving in a circle. I wonder at time 0 where it is. So if we plug in 0 for t into our original problems, sine of 0 is 0, and 0 times 7 is 0. So the x value will be 0. And then cosine of 0 is 1 times 7 would be 7. So the object would start right there. Right? Then if we increase the t value, let's do like 30. So 30, sine of 30 would be 1/2, so that's 7/2, so 3.5. And then cosine of 30 is square root of 3 over 2, so that would still be positive. So that's interesting. This object is actually moving clockwise. Do you see how I figured that out? By plugging in one value of t and then plugging in a bigger value of t, since time always goes upward. That tells us that our object is going around and around the circle in this direction. Which would be important if they asked you for the orientation of the graph. You would need to know what direction your object's moving. Clear as mud, or we get it? We're good? I have some other examples. We're not totally done. What time do we have here? Alright. Darn it. We might actually just have to finish this next